Hi, in this video we're going to take a brief look at classes in Python. Now this is a subject that we'll come back to in a lot of detail in the object-oriented section of the course, but I just want to show you some basic things about classes in Python. You should already know about object-oriented programming, so a lot of the concepts I'm going to show here should already be familiar, but I want to make sure that you also know how to do it in Python. And we'll keep it quite simple. So let's say that we want to create a class. To do so in Python, we use the class keyword. So we're going to define a class using class. So let's go ahead and create a rectangle class. And now we want our initializer. Now the initializer in Python is called or is implemented using this dunder_init method. Now the dunder_init method is actually a method that runs once the object has been created. So there's actually two steps when we create an instance of our rectangle class. We first have this new step. If you come from Java, you know about new. So we've got the same thing in Python, but then the initializer is a step after that. After the object's been created, then we can go on to the initialization phase. So what happens in Python with these instance methods is that the first argument of the method is the object itself. So our first argument is going to be the object. We typically call it self. You can call it anything you want, right? You can say, new object that was just created, right? You could do something like this. So this would be the first argument. But it's customary and you should use self because everybody knows what that means. So self means the instance that was just created. And then in addition to this, in the init method, we're going to require the width and the height. And so now we're going to set properties, attributes of the class. In this case, they're going to be value attributes, so we call them properties as opposed to methods, which are callables essentially. So this attribute is going to be called width. So we're going to say self.width. So we're going to say this object that was just created, that's called self, that's what gets passed into this first argument. Python does that for us. We don't have to worry about doing that. So self.width equals width and self.height equals height. And I know if you come from a Java background, you're probably kind of screaming right now saying there's no data encapsulation going on. And you'll see why it actually doesn't matter in Python. So let's go ahead and create this class. So now there we go. We have our class and we can create an instance of that class. Let's say a width of 10, height of 20. And now we can query the width. There we go. We can set the width. Okay. And then we can query the width again. And we see that we have that. So that's great. Okay. We were able to create a very simple class with two properties, width and height. So the next thing we're going to look at is adding attributes that are actually callables or methods. So I'm just going to copy paste. And let's go ahead and add an area method. So area. Now area is an instance method. It's going to need to receive the object that we are working on. So again, we just use this self. So here, what do we want to do? We want to return self.width times self.height. Okay. And let's go ahead and do a perimeter as well. Perimeter, self again. And then here we're going to return 2 times self.width plus self.height. Okay. So now we have a class that has two properties, width and height, and two methods, area and perimeter. They're basically just functions, but they're special functions because they get called using that dot notation. So for example, let's say we do this, 10, 20. Now we can again call width and height, but here I'm going to call area. Now area is a callable, so I need to make sure it gets called. It doesn't require any arguments other than this object. So why am I not putting it in here? Well, it's actually over here. When I say r1.area, what Python does, it calls this method area that's in the rectangle class, and it takes r1 and passes that as the argument that we've called self here. So again, this doesn't have to be called self. It could be called, you know, something. So I'm just going to show you. This is a terrible idea, but I'll just show you that this will work just equally well. So let's go ahead and rerun that, redefine our object. So now we can call the area, and we get indeed 10 times 20, which is 200. And we can call r1.perimeter. And we indeed get 60. So as you can see, that worked just fine. However, let's just go back and let's call this self. Okay, this is the traditional way of doing it, and that's the way you should do it too. And why? Not because you have to. Python doesn't care. It's other readers of your code. If they see something else than perimeter here, then self here, they may be thinking there's something going on that's different, because we have other kinds of things that we can do. We can have class methods, we can have static methods. So if you don't call it self, it's not immediately, you know, visible that this is just an instance attribute. So be careful with that. Just stick to the conventions on that one. So now we've seen with various objects in Python that they have string representations, right? You can usually print your object out, like, you know, an integer or a fraction or decimals and so on. They have string representations, lists as well. So what about our class? Well, let's go ahead. Let's say, let me make sure I rerun all this. And let's go ahead and look at string of r1. And we get this thing over here that says we have a rectangle object in our main. This is the module we're in. It's the main module at some memory address. So this is the memory address of r1. In fact, we can do hex of ID of r1. You'll see that it's the same address, 936A0 and all that stuff in front. Okay, so that's obviously not what we want. We'd like probably, you know, a little bit better representation. Like, for example, saying, well, it's a rectangle with this width and this height. That might be something we want to do. So this is done. We can just create basically using a method, right? So let's go ahead and I'm going to copy this code, paste it over here, and let's add a method. Let's say def, and let's call it toString. If you come from the Java world, you know what this is. We can call the toString method to get the string representation. What do we want to do? Well, we're going to return, let's say, we're going to call this is a rectangle, and we're going to say the width equals the width, and the height equals, if I can type, equals the height. Okay, and then we'll format this with self.width and self.height. Okay, so now let's go ahead and create another rectangle. Let's say 1020. Let me shift that over. And now I can call string r1. That still brings that out, right? This thing over here. Why? Because we need to call toString. So what we really need to do is to say r1 toString. Okay, so that kind of, you know, that stinks, because we can't use this, which is the traditional way of doing it with the built-in classes. But this is where we can really take advantage of the way Python goes about allowing us to overload this thing, to basically define what does str mean. Str by default, you know, is just going to look at the class and the memory address of the object. So how do we override this essentially and provide our own definition for str? Well, it's very simple. We have these special methods that Python has. Now, people call them magic methods, but there's nothing magical about it. They're well documented and they're well known, right? You know, so they're not magical. They're not hidden or anything like that. It's not, you know, a black box. So the special method name that we have to use here is called dunder str. So dunder means double underscore, double underscore. Okay, so dunder str. And if we do this, now we can just rerun this code, and now you'll notice that when we run str of r1, when we call the str, the built-in str function on our object, which is a custom class, we get that string representation. Now, if we just do R1, and this is kind of specific now to Jupyter Notebook and to the Python interpreter. If you're running, let's say, in a Python console, and you just call the object this way, or what happens is that it's still going to return this. Now, that's not the functionality we get if we have a list. Let's say we have a list, 1, 2, 3, right? We can convert list to a string. We get this, right? That's the string representation. Or we can also just do this. We can say L, and then we get this representation here. You'll notice it's not telling us, hey, this is a list at some address. So what's happening is that it's a different special method that we need to implement. And we'll get back to this one in a lot of detail as well. But for now, it's called REPR, repr. It's basically representation. And the representation typically is, if it's possible, a string that shows how you would build the object up again. Now, in some cases, there's too many variables, you can't do it. But in this case, we can, so we're going to choose that. So how did we actually instantiate this object? Well, we called rectangle, and we passed in two parameters. We passed in the width and the height. So let's go ahead and create that. So now I'm going to run it again. Now our string representation hasn't changed. It still says rectangle with width is 10, height is 10. But now if I do it this way, you'll notice that I have rectangle 1020. And so what comes out here, this string, if I was to execute it, it would actually create a rectangle with width 10 and 20. So that's what the representation is used for. So now how about equality? Let's say that we have this rectangle R1, and let's say we have R2 equals rectangle, and we'll make it the same. So R1 and R2 are basically the same rectangle. But you'll notice that R1 is not R2, right? They're different memory addresses, they're different objects, different instances of the class. But if we do R1 equals R2, we get false. Now we really would expect that, you know, as a user of rectangle, if it's got the same width and height, it's the same thing, it's the same value, right? The object might be different, but it's the same value. So how can we do that? Well, it's very simple. We have again a special method in Python, which is the dunder EQ method. That allows us to basically specify and define how we can compare our objects to each other. So let's go ahead and implement that. Again, I'm just going to copy this code, paste it over here, and we're going to basically keep going. So we're going to implement this dunder EQ method. Now, the dunder EQ method is an instance method. It's going to take self. If you look at this line of code, R1 equals R2, then there's actually two objects, right? We're comparing two objects. So R1 is actually going to get passed into the self argument, and R2 is going to be the other argument. So we're just going to call it others, the other object. Now I'm going to keep this simple initially, but we will need to add a little bit more to make it more complete. So for now, what do we want? Well, we want to say two rectangles are equal if their width and height are the same. So let's go ahead and maybe write it this way. Is equal. Actually, we're just going to return it. So we're going to return self.width equals other.width. We want to make sure the width is the same, and self.height equals other.height. So we can do it this way. If you're used to tuples, you could also actually do it this way. You could say self.width, comma, self.height. This tuple should be equal to the other.width and other.height. Okay, we could do it this way as well. However you want to do it, I think this one is probably a little bit more expressive. You know, self.width equals other.width and self.height equals other.height. I tend to prefer this, but up to you. So now let's just make sure this works. Let's go ahead and create a rectangle of size 10 and 20, and let's do another one. Okay. Now R1 is not R2. That's still true. They're different objects. However, R1 is equal to R2 using the equality because in terms of values, they are the same. Now, there is one problem though. Let's say I say R1 equals 100, okay? We have this problem here. The int object has no attribute width. Well, yeah, what happened is that this equal method was run and we're trying to get other.width and other.height. Well, integers don't have those properties. So we need to fix that. And let me go again, just copy paste. Let's fix this up. And what we really want to make sure is that other is an instance of rectangle. Now, we'll get into that in later sections, but I'm not going to use type. Type is too restrictive. If I use type, I can find the type of other, and it will tell me if it's a rectangle. But what it doesn't handle is if I've subclass rectangle, and now I want to use the equal method. If I check the type here to be specifically a rectangle, it's not going to work with subclasses. So in this case, what I'm going to do is I'm going to say if is instance. So instance will work with subclasses. And what is that? Well, I want to make sure that other is an instance of rectangle. Okay, that's one way of doing it. Or I could use the class property of self, but in this of other. But in this case, self. But in this case, I'm just going to hard code it to rectangle because I'm not really looking for it to be anything else. And if I subclass it, this is still going to be correct because isInstance is still going to do that correctly. So if I have an instance of a rectangle, do this. Else, you have to return the not implemented value. Actually, no, we're going to return false. Okay? We're just going to say that if you're trying to compare a rectangle to something other than a rectangle, they can't compare equal. That's always going to be false. Okay? So we'll go ahead and write it this way. So this is now a little cleaner. And we can go ahead and create our two rectangles again. I'll copy paste that. And then R1 equals R2, that still works. And now if we say R1 equals 100, we get a false, which is true, right? That's the correct answer. R1 is not equal to 100. Now, what about methods like comparisons, like less than? So operators like less than, greater than, less than or equal to. Well, we also have special methods we can use to implement those. They're methods like dunder LT for less than, dunder LE for less than or equal, dunder GT for greater than, dunder NE for not equal, and so on. And these are all well documented. So let's just go ahead and write one. So again, I'm going to take this code, copy paste, and let's implement the less than. Okay, so let's implement less than. And again, we have two, right? The less than operator is a binary operator. It has two operands. So we need self, which is going to be the left-hand operand, and then other, which is going to be the right-hand operand. So let's go ahead and implement that. When is a rectangle smaller than another one? We're going to do it based on the area. Now again, it's up to you as the writer of the class to define how you want to define, ordering in your rectangles. I'm just choosing to do area. So again, though, I'm going to have to check the instance. I don't want to try and compare a rectangle to, an integer. So I want to make sure that other is an instance of rectangle. And I'm going to return here that self.area is less than other.area. Okay, that's all I need to do. I need to make sure that the area of myself is less than the area of the other. Okay, whatever this computes to will tell me if it's less than or not. And if it's not, now here we don't return false, right? But logically here, what I really want is something else. So instead, I'm going to return the not implemented value. We'll get to this later, but we don't raise an exception. We just return not implemented. This is a little different. Okay, so now we have that. Let me go ahead and copy paste these two. But now I'm going to make 100 and 200. So obviously R1's area is less than R2. So now I could say R1 is less than R2. And name instance is not defined. What have I done? If is instance. Sorry. Okay, if is instance. Just like I had over here. So let's rerun this. R1 is less than R2, as you can see now, actually returns true. So we implemented less than. So R2 is also a rectangle, so we could say R2 less than R1, obviously, and that's false. What about R2 greater than R1? We haven't implemented greater than, but if you look at what happens, it returns true. And that's because what happens is that with R2, Python called the dunder-gt method, greater than. It wasn't implemented. So what it does for us, it basically flips this around and says, okay, well, if R2 is not greater than R1 is not implemented, how about R1 less than R2? And in this case, well, R1 less than R2, that less than is implemented, so it worked. But obviously, you're not going to get things like R1 less than or equal to R2. That is not implemented. Okay, so it says it's not supported. We would have to implement those ourselves. Now I want to look at these properties that we had, width and height. And let's go back to a slightly simpler version of the class. So we have class rectangle. Let's go ahead and put that in. I'm just going to take out area and perimeter just to simplify the code a little bit. Okay, so we have this class, and we saw we can basically say rectangle 10, 20, right? And then we can look at r1.width. Okay, it tells us what the width is. We can set the width as well. We can say r1.width equals, let's say, negative 100. Okay, and now if we look at r1.width, well, that's negative 100. In fact, r1 we can see has a width of negative 100, and its height is still 20. So a few things going on here. One is that we're allowing direct access to the width property and the height as well, but I'll focus on width. Which means that, in particular, users can set this to negative 100. And we may want to put logic in here that stops people from setting the width to a negative value. It doesn't make sense to have a rectangle with a negative width or height. It needs to be positive. Even 0 doesn't make much sense. So the way you do that in languages like Java, for example, and in Python as well, is we implement methods to get and set the properties. So what do I mean by getter and setter methods? Well, let me show you. Let's say we write a getter method. So basically, I'm just going to say get width. And here we're just going to return self._width. Well, self.width. So the first thing I'm going to do here is make width and height private variables. We don't have private variables, true private variables in Python. There is no such thing. So instead, this is a convention. If we put an underscore in front of our variable names, in front of our properties, basically we're telling, and same thing with the methods too, by the way, we're telling other users of our class that, hey, this is a private variable. Please don't touch it. Don't modify it. Don't mess around with it. But of course, if they want to, they can. If something blows up, that's their problem. That's their fault. But it's still possible to change it. Now, it might be in some cases that you have, a user of your class that knows exactly what's going on, and there may be a reason why they want to change that attribute directly. Here, what we want to do is we want to encourage people to not use width and height directly, but instead to use the getters and setters. So we might do it this way. Let's go ahead and write the get width. So we start with _width _height. And now, okay, well, first of all, with the string, and I'm not going to put it here, I'm going to put it above. But let's just fix the string and all these things first, because you'll notice that they're using self.width. Okay. Well, in this case, I'm going to use the internal, that's _width and height. I'm going to do the same thing here. All right, we have to do that here, and I have to do that here as well. Now, I've got to be careful here. I mean, I can still do this, so let's go ahead and do that. And I'll come back to this and explain why you got to be a little careful here. But let's first get this going. So I've got all this self_width and self_height. So I fixed up my class. Okay, I had to make all these changes because I changed what this was. Now what I want to do is I want to implement a getter and a setter method. So let's say get width self. So we'll just return self._width. So basically this get width function does nothing more than just return the width. Okay, and then we have set width self width. And here we want to do something a little bit different. We want to stop people from putting in negative values. And I'm also going to, not allow 0 values. So I only want positive. So I'm going to say if width is less than or equal to 0, I'm going to raise a value error. I'm going to say width must be positive. Okay. Otherwise, I'm going to say self._width equals width. So basically now I have a method that I have to call to set the width. And I'm going to copy paste those and do the same thing with height. Actually, you know what? Let me leave out the height just for a minute. Okay. So let's just work with the width. Okay, so now I have this class that has private, pseudo-private variables, width and height. Pseudo-private properties, instance properties, width and height. So now I can create my rectangle. If I try and read the width, I have an attribute error. It has no width. Now this one is going to be a little odd. If I run this, you'll notice that no error happens. Now, we'll get back to this later in the course, but this is called monkey patching. Essentially what I've done is I've added a property called width to R1. But I've done this at runtime, and Python allows us to do that. So there's a lot of problems going on here. The width, it's still, this width property is -100, but the underscore width is still 10, right? It was created as 10, 20. In fact, if we print out R1, we have 10, 20. So there's a lot of things going on here in that now the person said R1.width and that created a new property. We also now are able to say R1.getWidth, and that's the way that people should be accessing the width, not the underscore width. They should be accessing it using getWidth. And to set the width, now we have to use the setWidth property, and we can say set it to, let's say, -10. Now you'll notice what happens now is that we have a value error. The width must be positive. That's exactly what we wanted. So now we can say set width, let's say, to 100, and that now worked correctly. In fact, we can see the width is 100. But you'll notice what happened is that if we had released this class, a while back, and we had it the way we originally had it, then people all over the place were using R1.width to read and to set the property. Maybe we were using our rectangle class all over our code, or maybe a coworker, we're working in a team. Other people are using it. And now I go back and I say, well, no, you can't do that anymore. You have to use this get and set methods. Well, that just broke everybody's code. So in Java, we usually don't start with the, what we had before, with the bare properties. Instead, we always write getters and setters from the get-go. And very often the getters and setters are nothing more than something like this. We don't even have the rest of that code here. We start with that. And what this means is that if we now have to put in logic like this, we go ahead and put it into the setWidth, and it hasn't broken anybody's code. So that's one of the main reasons why you do this. You set up your encapsulation this way so that you can have control over how you get and set the properties. I'm not even going to talk about calculated properties. For now, I'm just talking about actual physical, concrete properties. So that's the typical way of doing it if you come from a Java background. You don't start with this, okay? So let me show you why in Python it doesn't actually matter. So I'm going to keep this, but I'm going to copy paste the code, and I'm going to show you the Pythonic way of doing this. So I'm not going to implement these things over here. I'm going to go back to the original class that we had, okay? So I'm going to go back to this. I'm going to remove the width, the underscore, okay? I'm going to remove the underscore. I'm going to remove the underscore here, and here, and here, and here, and here. Okay. So now I've gone back to my original class. So I can say R1 equals rectangle 10, 20. I can read the width, I can set the width, I can set it to a negative value, and I can look at R1, it tells me okay. All right, so this is what we had before. That's what we, released, let's say. And now we realize that, well, we really want to stop people from setting the width to negative 100. So what's the solution to that? Well, the solution is exactly what I showed you before. It's writing a setter and getter. But we want to do this without being, without breaking our backward compatibility. And Python allows us to do that. And that's the reason why you don't have to start with getters and setters right away for variables. So in Python, unless you know that you have a specific reason to actually implement a specific getter or setter that has extra logic, you don't implement them. You just leave the properties bare that way. That's perfectly fine. First of all, there's no such thing as private variables, so anyway people can modify it directly. And secondly is, don't force people to use a getter and setter unless they have to. And really what happens in Python is that they're not even aware that they're going to be using a getter and setter if we implement those. It's going to be transparent. But Python is going to have to go through and actually run a method instead of being able to access width directly. So if it doesn't have to do that, it'll be a little more efficient. How do we go about doing this? Well, we're going to write a function, basically an instance method that is going to return the width. That's going to be our getter. But what we do is we use these decorators. And so we use the special syntax. We'll use the at property, and we'll get into what decorators are later. For now, I'm just going to use it. And we're going to call it width. So now this is a method called width. So here, what I'm going to do is I'm going to go back to using the underscore width. And I'm going to go back to using the underscore height. Okay? This means that I have to fix things up over here. Self.width, self.height. Well, maybe not. Let's see why not. I'm going to leave that code as is for now. And let's go ahead and just finish up writing the properties. So I'm going to write a getter for width. This is what this is going to enable me to do. It's saying, okay, this function that comes after here is a property. So it's going to be called width, and it's just going to return self.underscore width. And then I'm going to do the same thing with height. Height, self. I'm going to return self.underscore height. Okay? And let me go ahead and run that class. So now I can go ahead and create this new rectangle, and I can read the width. You'll notice that worked. But what did it run? It actually ran this function. Let me just show you. I'll put a side effect. Never a good idea to do that. But width, let's call it, let's say getting width. Okay? And let me run it again, and you'll see it's printing out getting width. It went through the width method. But you'll notice how I accessed it. There wasn't a call here. I didn't say r1.width parentheses. Basically, because I used this property here, Python now is able to access the width via the getter, and I didn't have to change any code that was actually using .width as the direct access to the property before. So I now have a property that goes through a method for the getter without breaking backward compatibility. This is why you don't have to do this right off the bat, and you shouldn't do that right off the bat. You should only do that if you need to. In this case, I need to because I want to stop people from setting width and height to a non-positive value. So I've got that for the width, I have that for the height, but of course if I try and set the property, that's not going to work because I don't have a setter. So now I need to write a setter. So let's go ahead and write the setter. How do we write a setter? Again, we have to use a decorator. And so here, the way the decorator works is we have this width property. So we start with the width and then we say dot setter. And you'll see how all this works when we deal with decorators and classes later on in this course. So the width.setter, the name of the method is actually the same. Okay, now don't be confused. We do not have overloading in Python. Okay, you don't have overloaded methods, this way. Don't think that this is like other object-oriented languages where since we have now the width that we need to pass in, you could say, well, this is a different signature than this one, so it's two separate functions. It doesn't work that way in Python. We don't have that, and we'll see that later. But the reason why this is okay is because this actually modified what this function is. So this function and this function are not stepping on each other's toes. All right, but anyways, this is how we do it. And then here, we're going to set the width, but we want to put in our clause. We want to say if width is less than or equal to 0, raise value error, width must be positive. Okay. Else, what are we going to do? We're going to set our internal width variable to the width that was passed in. So this is how we create a width setter. And let's do the same thing for the height. I'm just going to copy paste that because most of the code is the same, except this becomes height. We're setting our height setter. Height, underscore height as well, and this should be height as well. Okay, so now we have our getters and our setters. So we can go ahead and run that. And now this will work the same as before for getting the value, right? So r1.width. Am I doing this wrong? Because height.setter, that's that's called height. Okay, so I missed that one. Let's redo this. So now our width is 10, right? And we can set our width to -100, and now it tells us, you can't. The value must be positive. Now we could do r1.width equals 100, and that works. In fact, if we look at the value of r1, we have 100,20, which is correct. So you can see that we didn't break backward compatibility. We didn't break backward compatibility by implementing getters and setters. That's because we did this using properties. So it's okay to leave your properties bare initially until you need to do something, in which case, go ahead and implement something like this. You can do that without breaking backward compatibility. So this isn't like Java where you should always implement getters and setters from the get-go. Not in Python. I know I'm rehashing this. We'll come back to this later, but that's kind of important. Okay, the next thing though is that I want to clean up this code over here. You'll notice that it's calling self.width and self.height. Now, there's actually nothing wrong with doing that. Why? Why did it work? Well, self.width is going to do what? It's going to call the width getter. And it's going to do what? It's going to return underscore width. So it's perfectly fine leaving that here this way. Now in this case, however, maybe I want to avoid calling the method, the getter method, and so I might actually, do it directly. Kind of depends. I choose not to do that initially. I prefer getting and setting my data, even inside the class, using the getters and the setters. This way, if I have any logic in the getter that's being implemented, I'm going to pick up that logic for free right over here. And that's kind of what I want, right? But maybe in some cases you want to speed things up. Maybe there's something and you don't want this extra call to a function in order to get the value. You just want to hit it directly. That's possible too. Okay, and we'll talk about those kinds of issues later on. Okay, the other thing too is that I want to show you that I could do this. I could say R1 equals rectangle minus 100, 20. And that's perfectly fine. It allowed me to now instantiate a rectangle with a negative width. And I don't want that. So of course I could go in here and put in a, if width is less than or equal to 0, raise value error and blah, 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 and so on. But instead, what am I going to do? I'm going to do this. I'm going to actually call the setters inside my init method. And then the setter is going to handle, raising an exception if it needs to. So let's go ahead and redo this. And now let me go ahead and try and run and instantiate this rectangle. And indeed we get width must be positive. So again, I got that thing for free by using internally the getter and the setters in my class. All right, so this is kind of the basics of classes in Python. I really wanted you to understand about how you create classes, how you define classes, how you initialize values inside the class, why it's okay to have bare properties in Python classes, and if you really need to implement getters and setters, the best way to do it, which is the approach I just showed you, and also these special methods that we have that allows us to bring, standard style implementations to our own classes, right? We saw how we could use the built-in string function to actually, customize how we want our rectangle's string representation to look like. That was by using these special dunder methods. All right, thanks for watching, and I'll see you in the next video.